Welcome to IPM Works e-learning modules. My name is Tito Caffi and I'm an associate professor of the Università Cattolica del Sacro Cuore from Italy. This video is part of the module 4, Integrated Disease Management, and it will present the chapter 4.1, Current Challenges in Disease Control. So when we are talking about the challenges we are facing in agriculture, we can consider three main aspects, which are, of course, the climate change. We can all see the result of it in our fields. As a second main point, I would say we take into consideration the need and request to reduce the use of plant protection products. Last but not least, the resistance management. So the strategy and the techniques we should put on field to avoid the appearance of strains which are resistant to the fungicide we can use. Of course, climate change is something that is under our sight. If you consider the World Economic Forum reports in the last years, they are always focusing on the global risk effect caused by climate change or the not efficient response we can put into practice to mitigate the effect of climate change. They are also considering in these three big pillars as the three bigger risk, also the biodiversity loss and extreme weather as a serious threat. This means, of course, that we have to take it into serious consideration. We have to manage it. We have to modify our behavior according to the climate change. And what actually is climate change and how it is impacting on agriculture and, for instance, on yields. Majorly, we can say that the increase of temperature worldwide is also increasing the productivity. But of course, this is not a general concept, because in some area we have too much increase, so we have actually a decrease of the yield. In other area, particularly in the northern area of the world, we can have a beneficial effect. Of course, we have to consider the global average of this, and so we have to grab some occasion, for instance, and some possible modification in our behavior, in what we are cropping, and how to manage the crop in a let's say, mid to long term strategy. How much is the climate changing? I'm using these data to show you the Euglen index, that is basically an index based on temperature, on local temperature, mean and maximum temperature, to calculate how much an area is, let's say, a good location for cropping vines, for cropping grapes. And this is the dot on the scale from 1,400 to 2,800. The blue dot is the climatic area, the climatic Euglen index based on the climate in Piacenza, in the north of Italy, where I'm from. And we can see that in the last 15 years, we have an abrupt change. We are actually considerably higher than there. In the box plot, you can see the minimum and the maximum level, which are far above the Euglen index based on the climate from the 70s to 2010. And here we have, for instance, the season 2019 compared with many different famous location, from quite cold location in Germany and in Champagne, for instance, in France, to very hot location, traditionally like Napa Valley or so. So the temperature is increasing and we are facing a difference. We have to manage this difference if we consider the last 12 season in our very small experimental vineyard in the campus of the university here in Piacenza. We can see that the weather anomalies, so how much the weather was higher or lower compared the average of temperature was higher or lower compared to the climatic average, or it was higher or lower compared to the rainfall. We can see that in the last 12 years we only have 2 seasons which are more or less within the average. Then we have 2 seasons, 2013 and 2018, and most probably 2023 will be here around with a very huge impact of a lot of rainfall, while the remaining season they were all very hot and very dry. So we have to adapt our way to crop to the local situation and how much it is changing. Of course, when the climate is changing, the plants react. And how they can react, they feel the temperature and they modify their phenology. Again, this is an example with grapes, and we have different years of bud break. We have in the 1940, we have the very first data set of the bud break according to the day of the year. Then in the 70s, in the 80s, and in the last year, from 2014, 2017, and 2018, we can see there is a earlier bud break that is appearing. Why? Because the average temperature, particularly during the winter time, are increasing. The plants are reacting to them, and they are starting bud break earlier. I'm putting at your attention this graph on the left-hand corner of the video, where we have a simulation of the phenology of grapes with 2 different data set, expecting let's say longer winters return, so with more, let's say, frost during winter time, and a mixed situation getting a little bit warmer. In both cases, we have a bud burst that is earlier than we are used to. So we are going toward a continuous reduction and an extension of the grape growing season. This is just an example for grape, but we have to consider that with the climate change, we will face longer season where we have to manage diseases. And of course, also pathogens are reacting. These are 2 main diseases of grapes. We are talking about downy mildew and powdery mildew on the right side. We have incidence and severity. We are talking about untreated plots. So those data are referred to incidence and severity on clusters, on bunches, into untreated crops in our experimental vineyard at our faculty in Piacenza. I'm showing you this data just to tell you that, okay, we have the climate that is changing. We are facing an increased temperature, a slight reduction in the amount of rainfall, but the pathogens, the diseases, are still there. Even if we are used to have very hot season, downy mildew is always present. So it means that we, even after a climate change scenario, we have to consider the presence of disease, and we have to consider they are adapting to the availability of what? Of temperature and rainfall. We can have a longer season because of temperature, but whenever we have rainfall, and 2023 from this side is a clear example, whenever we have rainfall, the pathogen are starting again to cause a threat. So we got to be ready, and we got to be prepared for managing them. We are under an umbrella, let's say, a big framework where we are required, and also there is the need, even commercial needs, to reduce the amount of plant protection product we are applying. The 2030 goals are really clear. We have to reduce the amount of pesticide. In particular, we have to halve the most risky and hazardous pesticide we are using in agriculture. We have to reduce by 50% the nutrient losses. We have to reduce the antimicrobials used for animals and aquaculture, and we have to increase organic farming. So let's say, in a political way, the roadmap is quite clear. We have to consider this. In this table, we can see, I would say, the most relevant crop across Europe. We have very large area cropped with cereals in terms of surface of agricultural land used. Wheat, of course, is the first crop, and because of this, its extension is the second crop for total use of pesticide in it. But if you look, for instance, grape, even if is only the sixth cropped in Europe, it is the first one with almost the 30% of the whole amount of plant protection products used on it. So most probably we have to keep using plant protection product. We have to rationalize, we have to do it better. And particularly, I'm showing you this result of a study we were conducting here in collaboration with our friends from the JKI in Germany, and we were comparing with different models. I don't want to get into the detail, but those indicators you can see in this table are classifying. We have different approach and different way to calculate, but they are quantifying, let's say, the impact and the risk of different compounds. We have, for different classes, the number of molecules that we can use today across Europe compared to the CFS, so the candidates for substitution. Those products that we are allowed to use in agriculture, but they are, let's say, under the observation, because as soon as we will have a different product with a better environmental profile and a similar efficacy, we will have to cut them. And you can see that with the candidates for substitution, actually we have a problem of impact, because all of them they have a higher impact compared to the rest of the molecule for fungicide, herbicide, or insecticide we are using. So probably, yes, we have to consider and to respect the requirements for reduction, but probably we can do as a main goal, we can take as a main goal the reduction of plant protection products, and in particular of candidates for substitution, in order to reach the goal requested by the EU, in order to have a global reduction of 50%, focusing on candidates for substitution. because with only 36% of reduction and 24% of reduction of candidates for substitution, we can get those goals. Today, in fact, we are a little bit far from the uh, requested goal from the EU to reduce by 50% the chemical pesticide, and by 50% in particular the more hazardous pesticide. Focusing on candidates for substitution, so on the left side, or sorry, on the right side of this slide, we should get a proper goal with not very big effort. And of course, we will see in the next module of this course how HiPM can be a useful tool for reaching that goal. Of course, a key point is resistance to fungicide. We have a situation, we are observing an evolution where many strains of resistance to fungicide are appearing. And this is absolutely natural. The evolution is, let's say, mutation that is part of the resistance to fungicide is a key part of evolution. So nature will try to help fungal strain to survive to the pressure caused by fungicide. We can see here a specific case in France, so the resistance to the QOI, that is a specific class of fungicide, quinol outside inhibitors. They were used for managing wheat, for instance. And you can see that in less than 10 years, for a small portion in the northwestern part of France, the appearance of a resistant strain was spread, and the frequency was reaching 100% all across the country. Of course, we can see over the years a reduction in the use of the QOI, because when the resistance is appearing from the other side, we tend to reduce the amount of fungicide we're using. And for instance, we can replace the treatment with DMI in a specific case. Of course, we have to keep in mind that resistance is an ongoing process, so the pathogen strains will try to overcome the effect of the fungicide. From the other side, we have to manage the application, of course, to get the result of protecting the crop, of course, to get the result of impacting as minimum as possible the environment, so respecting the requirements of reduction of plant protection products. But we have to keep in mind that we have also to protect the fungicides themselves. So we have to apply anti-resistant strategy. Again, on different fungicide used against septoria leaf to control septoria leaf blotch on wheat, we can say the change in fungicide sensitivity across a little bit more than 20 years for different substances. Of course, the increase of the EC50 means that there is we need more fungicide to control, to reduce the fungal growth by 50%. So the green box for each fungicide is showing us, particularly for propiconazole and prothioconazole, that we have some resistance ongoing, so we need more fungicide to obtain the same result than in the previous season, in the previous years. This is a crucial point. We have to keep in mind that we have to protect the crop, but we also have to protect the fungicide we are using. And just to change from wheat and to move in the vineyard again, we can see here a map, a world map, where we have in green the grape growing area in terms of hectares. So the darker green means higher density of plantation for grapes. And we can see in the following map fungicide resistance observed. Worldwide, where we are more or less where we are growing grape, we are observing some resistance. So the phenomenon is ongoing and we have to work on it. Thanks a lot for your attention, and let's see you for the next module of the IPM Works e-learning